Kirchoff's laws 2. Calculate the three currents I1, I2, and I3 indicated in the circuit diagram shown in figure. So I1 is flowing in this direction, I2 to the left, and I3 to the right for these three branches. Now, you can see that I can use Kirchoff current law for the given directions of I1 and I2. Because I3 is flowing in this direction, it's approaching this junction, and I1 is approaching this junction. Therefore, the current that leaves this junction should be I1 plus I3. And similarly, for this part here, because I2 is approaching the junction, I3 is leaving the junction, we should have this current equal to I2 minus I3. So I2 minus I3 will be flowing in this direction. So let's see. I3 is leaving the junction. So I plus I3 minus I3, they will cancel out. I2 is leaving the junction, so it will be minus I2, but I2 is here entering this junction, so plus I2, so it will add up to 0. Now, there is this current I1 plus I3 approaching this junction, I2 minus I3 approaching this junction. If I add these two up, I will find I3s will cancel and I1 plus I2 will flow through this branch of the circuit. Now I can write, because I have three unknowns, I need three equations. I can write three Kirchoff voltage laws. So that one for this loop, one for this loop, and one for this loop. So let's start with this one, and let's start at this point. So what am I going to see here? I1 plus I3 will be flowing to the left, so this will be plus, this will be minus. I1 plus I3 times 8, then there's nothing here. I1 is going from plus to minus, plus I1, then I encounter a minus 9 volts to reach this point, back to this point again. So let me rewrite this KVL1 equation. KVL1 equation is I1 plus I3, which I have found using Kirchoff current law, plus I1 minus 9 equals to 0. So this gives me an equation between I1 and I3. I have 8 I1 and I1 here. So this will give me 9 I1. And then I have plus 8 I3. This must be equal to 9, because this minus 9 will go to the right hand side as plus 9. Now let's go to the second loop, KVL2. For KVL2, I will start at this point. So I will, let's see here, I2 minus I3 times 5, so that will be in this direction. So if I take the loop in this direction, so this is going to give me plus 5 times I2 minus I3, then I will have plus I2 and minus 12 is equal to 0. So this will be in this sense, in the clockwise sense, I will be starting at this point and at this point. So KVL2 equation will be I2 minus I3 times 5, that is this potential drop here, and then there's nothing here, and then there is plus I2, and then I have a minus 12 to go back to this point. Minus 12 is equal to 0. So 5I2 plus I2 is 6I2, and then I have minus 5I3. This must be equal to 12. That's my second equation. Now I need KVL3, this one. And for this one, Let's start at let's start here, okay, and here. So let's start at this point. So for KVL 3, the first thing I will see here is plus 9 volts. So I will have plus 9. Then I will have minus 1 times I1. So I will have minus I1. So that takes care of this part. Now I go to plus I2 and minus 12. Plus I2 minus 12. Then I have this branch here, 10I3. So that's going to be plus 10I3 is equal to 0. So that gives me I1 minus I2 minus 10I3 is equal to minus 3. I multiplied this equation with minus 1, and now I see that this is going to be minus 3 on this side will become plus 3, taken to the right hand side becomes minus 3. So I have 3 equations and 3 unknowns. I can solve them simultaneously to find all the currents. So that's what I'm going to do next. So first I'm going to take KVL1 equation, 9I1 plus 8I3 is equal to 9. Then I will take KVL2 equation, 6I2 minus 5I3, 6I2 minus 5I3 is equal to 12. Then I will have the third equation, KVL3 equation, I1 minus I2 minus 10I3 is equal to minus 3 amps. So this equation gives me I1 is equal to I2 plus 10I3 minus 3. So if I substitute this for I1 to the first equation, then I will have 9 times I2 plus 10I3 minus 3, that's I1, plus 8I3 is equal to 9. So this gives me 9I2 plus 9 times 10, 90 plus 8, 98I3 plus 98I3 equals to minus 27, goes to the right hand side, plus 27 plus 9, 36. This is going to be 36. And then I have this KVL2 equation, which is 6I2 minus 5I3 is equal to 12. So what I'm going to do is I'm going to multiply this equation with 2 and this equation with 3 in order to get the coefficients of I2 to be the same. So if I do that, I will obtain 18 I2 plus 196 I3 is equal to 72. And from the second equation, I have 18 I2 minus 15 I3 is equal to 36, 12 times 3. Now, if I subtract the second equation from the first equation, 18 I2s will cancel. I will have 196 plus 15, 211 I3 is equal to 72 minus 36, 36. So this will give me I3 is equal to 0.171 amps. Okay, so once I know I3, I can use this equation to calculate I2. So 18 I2 minus 15 I3, I3 is 36 over 211, is equal to 36. That's this equation here. And that tells me that I2 must be equal to 36 plus 15 times 36 over 211, and this whole thing divided by 18, and that gives me for I2 2.14 amps. Now that I know I2 and I3, I can find I1. I1 is equal to I2 plus 10 I3 minus 3. So it is this equation here, 2.14 plus 10 times 0.17 minus 3. And this actually gives me I1 is equal to 0.848 amps. Okay. So this was a long calculation. So what I want to do is to check the result. So check for the grand loop. What do I mean by the grand loop? Well, that is this loop here, KVL5. I'm going to go through this loop and see that this KVL5 equation is satisfied. Okay, so let's start with first of all, let me write down the current values here. Here I have I1 plus I3. Here I have I1 plus I2. Here I have I2 minus I3. I2 minus I3. So I'm going to start at this point and end at this point. So because I2 minus I3 is flowing in this direction, this is plus minus. I1 plus I3 is flowing in this direction. This is plus minus. I3 is flowing in this direction. This is plus minus. Okay, so starting at this point, I have 5I2 minus I3, 5I2 minus I3. Then I have minus 8 I1 plus I3. So I'm here. Then I go to here. I have minus 10 I3. So this is 5 times 1.969 minus 8 times 1.019 and minus 10 times 0.171, and this comes out to be 0 as expected. So this is basically 0 volts, right? It's a voltage equation. So I can see that this checks. So the values that I have calculated should be correct. Okay, so another application of Kirchoff's laws, we want to find the three currents, I1, I2, I3. First thing I did was apply Kirchoff current law for this junction. I3 plus I1 is the current. The current that is leaving the junction must be equal to the current entering the junction, I1 plus I3. And for this one, I3 is leaving, I2 is entering, so I should have I2 minus I3 is the current leaving this junction. So I2 minus I3 plus I3 minus I2 is the one leaving. All the currents leaving the junction should add up to 0. And because here I have I1 plus I3 and I2 minus I3 entering, I3's cancel, I obtain I1 plus I2 leaving this junction. Okay, so once I have done that Kirchoff current law application, I consider 3 loops, KVL1, KVL2, and KVL3. For KVL1, I1 plus I3, the voltage drop is in this direction, I1 plus I3 times 8, no voltage drop here, plus I1, and then I obtain minus 9 volt here, so this is the minus terminal. Minus 9 is equal to 0, that's KVL1. KVL2, I start at this point and at that point, 5 times I2 minus I3 plus I2 minus 12 is equal to 0. That's KVL2. KVL3 equation, I start here, 9 plus 9 minus I1 plus I2 minus 12 plus 10 I3 is equal to 0, back to this point. So by manipulating these three equations, I can solve for I1, I2, and I3. The numbers that I have found, I can check for the ground loop. The ground loop is this loop, so I start here. Basically, I'm going in this direction, so this is not quite right. That's this direction. 5I2 minus I3 minus 8I1 plus I3 minus 10I3 is equal to 0. Is that equal to 0? That's what I'm trying to find out by plugging in the numbers I have calculated. And basically I see that this equation is satisfied, so I'm confident that these answers are correct.